This is Won-Seok Lee. I am the coordinator of Statistics Korea's official development assistance program, as well as with this workshop. On behalf of Statistics Korea, I'm really grateful that you have all made it to this workshop. And I think this workshop will opportunity to strengthen your statistical capacity in this very difficult time. Usually we hosted this type of workshop with the physical attendance, but this time during this COVID-19 pandemic, we think that it is more appropriate to host this workshop by online. So I hope that everybody would be happy with this workshop opportunity. Before we really begin, I would like to briefly introduce the workshop lecturer, Dr. Guy Abel. Dr. Guy Abel is a professor at the Shanghai University's School of Sociology and Political Science. He's also a leading researcher at the Asian Demographic Institute since 2015, and he's also research scientist at the International Institute of Applied Systems Analysis. He received his doctoral degree in social statistics from the University of Southampton in 2009. His research interests include demography, population statistics, and international migration, and so forth. Let's welcome Professor Guy Abel, who will lead this workshop. Dr. Abel, please share your lecture note.
Okay, thank you very much for the welcome. So let me just share my screen, right? Oh, cancel. I think you need to.
Okay, I will unshare. Yeah, I will stop sharing. Yeah. Hang. Okay.
Okay, share screen. Okay, welcome everybody. So maybe I just go through the first set of lecture slides that are in the Dropbox. Okay, here we go. Make it full screen. Okay. So today I'm going to talk about data analysis and visualization in R for beginners. And the idea of the sort of course is to introduce R programming for importing, handling, and visualizing data.
Dr. Abel, I'm sorry, but I'd like to ask everybody else your microphone muted, because that will create some howling. But if you have anything to ask or anything to discuss, please do so. But if another person is speaking, please keep your microphone muted. Thanks.
Okay, so maybe I continue, and yeah, I guess it's very much what I'm covering in the slides is a kind of introduction to R, and it's very much based around sort of using demographic data as well. Beginning R, if you're coming from a sort of perspective of using data with demography, although you can apply the methods to pretty much most types of data. So some of the main messages I hope that come across from the course is that you get a sort of understanding that R has many packages, and this provides many ways or endless potential ways to collect, model, and visualize data. We're just going to go through a very small sort of fraction of that, but there's really many different options to handle data, to visualize data in R. That hopefully as well you kind of get the idea about writing code and writing code in scripts. This can be a much more efficient way to conduct data analysis than using other sort of statistical software that you might have used before, like SPSS or Stata, or well, not so much Stata, but perhaps SPSS in particular, or Excel. We're going to focus on the tidyverse set of packages that have been around now 5 or 6 years, I think, since they sort of really matured. These provide lots of useful tools for importing and visualizing data. So, like I said, there's many different ways to do it now, but we'll focus on the tidyverse, which are a very popular approach to do things. And hopefully you get the idea that R does have a sort of steep learning curve, but it requires lots of practice. But I think it's getting easier and easier year by year. That R is there's sort of packages that are now coming out sort of really provide very helpful sort of syntax like language. So it becomes easier and easier to really learn R and to do quite complicated things quite quickly. Although it's still slower than perhaps doing it via like a point and click kind of program. So sort of little overview that we'll start off going through these slides, the sort of course interaction slides, and then I've got 5 other sort of sets of slides. So the first one's on sort of an introduction to R, so that's just talking about sort of basic R functions. Part 2 is visualizing data, so in particular we'll focus on the ggplot package, and then we'll talk about handling data, so how to import data into R that then you can visualize or model or work with. And part 4 is about wrangling data. So by that we sort of mean how to manipulate your data, join data frames together, filter data frames, rearrange them, for example. And then lastly, I just talk about some R resources, so sort of places to find help about R on the internet, or how to really find packages that might be useful to your work. So in the handout folder, there was a copy of all the slides and also the R code for the slides. So I wrote all my slides in R. So that means all the code there is attached in the how do we say, in the folder. Then throughout the course, usually I'm teaching this through about a week. So I'm just going to try and do it in a day. But in each of the slides, I sort of have a separate slide where I would stop and do an exercise. And so I really encourage you, if you're sort of listening back, to pause as well and do the exercise. Each exercise will probably allot about 40 minutes, maybe an hour sometimes, depending on how long it was. And this is really the best way to learn R, is to do your own practice, to do your own work. So I really encourage you to stop and work through the exercise. And if you get stuck, the solutions are in the solution folder as well. So we have 2 copies of the same R script, one that's sort of blank, where you can fill in the empty spaces, and the second one where you've got the solutions in case you get stuck. Okay, so a bit of background to R. So R is a language that actually developed or evolved from the S language. So the S language was predated R. This was developed by John Chambers and others at Bell Labs in the US. And essentially, S was written as a sort of shortcut from sort of other more mature programming languages like C. And S was kind of meant to be a statistical version of a language like C, whereas in C you might have to write many lines of code just to work out what the mean of a vector is, for example. And they sort of decided it'd be a lot more efficient if there was a sort of statistical language where you could just write one function and just one line of code, and you could get a mean, for example, and you can do many more complicated things than that, of course. So out of S grew a sort of the most popular version, which was S+, which was a sort of commercial version of S. And it became quite successful in let's say around 2000s, or maybe late 90s. And then around that time, R was sort of born, and this was written as a research project by in New Zealand by Rossi Naka and Robert Gentleman. And the idea was that R was written to be not unlike S, they sort of say, but I mean, in reality, it's basically very, very like S. I think it's better to say. You can sort of copy S code and run it in R, and it will work fine. So I'd say since the last 10, 15 years, S plus and S has sort of declined a lot, and R has really increased and taken over. And it's partly because R is free, and just the sort of package environment of R has, because it's open source, has become a lot more popular. So R is continually developed, and it's sort of managed by this group of statisticians called the R core team, who are based in the VU University in Vienna. And this is the website here, where you can sort of monitor the progress of R and find out some news, and also download R. So why has R become so popular? So I kind of hinted at this before, but of course, one of the main reasons is it's free. So there's sort of no cost to it. Second is that it's open source. So that means it sort of has this sort of core that I was talked about before, and that's evolve basically 7 packages that's loaded when you load R. But then you can download and install packages from many different sources. So I think I'll talk about this a little bit later, but there's well over 10,000 packages now in R, so it really gives you a lot of flexibility to do many different types of analysis. Okay, R is a sort of statistical language, so of course it can handle many different types of data structures, has many different options for graphics, and you can really get complete control over how a plot might look and really tweak everything about it. It's really become sort of leading software in statistics. So you find now sort of statisticians, when they develop methodology, they quite commonly write an R package to go along with it, so you can use the updated method as soon as you sort of become aware of it. It's also sort of been key, at least in sort of statistics and applied statistics, in reproducible analysis. So by that we mean you can essentially work with collaborators, send them your R script, send them your input data, and then they can run the code on their computer and maybe make some tweaks and update the analysis for them just by at the press of a button, or by adding a few lines of code. Whereas if you were using some sort of point and click based statistical software, that would be a lot harder. You have to write out the instructions of like click file, then open, and so on. It's less easy. Whereas in R, it's usually a matter of just running the code, which is just one button sort of action. And finally, I would say that compared to other sort of how would I say, other computing languages, at least, it's quite a very helpful and friendly user database. It's quite large now, and it's pretty active. So I'll sort of go through this towards the end of the course, but it's quite easy to find help on R, and there's some friendly places on the internet where usually, if you really do get stuck, you can post a question and get an answer quite quickly. Okay. So what's the catch? So why not everybody using R for data analysis? So one thing is it's not a spreadsheet. So it's not like Excel, for example. So you don't really see what's going on sort of inside as you do with Excel, right? In Excel, you can see all the data laid out. You can create a new column by sort of just dragging your mouse and then typing in equals and so on, and making reference to the other bits of data. In R, it's all sort of we tend to work using the scripts, where you sort of need to be familiar with your data already in the background, and to know how to sort of control it or plot it. So there's no real GUI, right? This graphic user interface. So you can't really do these sort of point and click operations that you might do with R. So usually in R, if you want to fit a model or you want to create a plot, then you need to write the R code. So I'd say there's still some kind of steep learning curve, especially if you've done no sort of programming before or writing code before. So that's obviously like something that if you want to learn R, that you need to get familiar with. and that can take a little bit of time. I still remember sort of the struggles early on when I was learning R. And yeah, finally, it comes with no warranty. So this is printed in capitals when you load R, right? It's free software, so there's no company that you can call up to figure out figure out any problems. Although, of course, like I said, there are places to get help. So this is just to demonstrate like a plot that the sort of difficulty and complexity of R. So this is what I'm talking about when I'm talking about the steep learning curve. So in R, if you want to do something quite complex, it's usually a little bit difficult, especially at the start. Whereas in Excel, you can do quite complex things quite easily, at least to start off with. But then as the complexity sort of increases, I find this is very true of R. Once you sort of get familiar with writing code and sort of learning a few functions in a few packages, then doing anything else more complex is just a matter of like getting familiar with how the new function works in a new package. And you've already done that a few times before. So it gradually becomes easier and easier to do more and more complex things. Whereas in Excel, you find you sort of hit a kind of limit where after a while, you can't really do anything else with the Excel functions. You need to start learning sort of VBA code or even more complex stuff. And then doing very complicated things in Excel can be very, very painful. Whereas in R, it's never usually any more painful than anything else. It's just a matter of installing a new package and getting familiar with how the function works. Okay, so this R project that we talked about, it's one of the main tasks it's responsible for is managing this comprehensive R archive network, which we call sort of CRAN for short. And CRAN sort of hosts this network, has sort of servers all over the world, and they host the R packages. So that means that this is where we can sort of download the R packages, and also we can download R itself. So I would encourage you, if you haven't already downloaded R, to click on the link here, and then go to the appropriate version of R that you need, depending on whether you've got a Windows or a Mac, and then download the install file. And then usually the installation is not a problem, just a matter of pressing OK and agree quite a few times. So R is updated regularly, so about 3 times a year. So usually the updates are quite minor, so it's not vitally important that you have an up-to-date version of R, but you tend to find over the year, as you start to sort of use new packages, then you might have to install R as well. So it's always a good idea to sort of keep R up to date. So this is what I'm mentioning here, that some packages might not be backwards compatible, and they might require that you do have the latest version of R, or that you at least have a version of R that's fairly up to date, especially when there's a sort of a big new version, when they change from, for example, R 3.0 to R 4.0, then you often need to make sure that you keep track of that and install a new version of R. Okay, so once we've downloaded R, we can load R itself by clicking on the sort of R icon in Windows. Maybe I can show this on my computer. Let me go to R. Okay, so you see I've got R here, and then you usually get 2 versions if you've got a 64-bit computer, and then when we load it up, we get this type of screen. Okay, so let me flick back to the version. So this is like the basic version of R. This is sort of what I learned R in many years ago. So it's sort of quite limiting, this version of R, and especially in the GUI, the graphic user interface. That when you sort of want to get to doing any work or maintaining code, it's not super friendly. So it does have a command line interpreter. That means we can sort of type into R. Let's go back to this to show this, right? This is where we can type in our commands. So if I want to do 1 + 2, for example, I can get the values out there. And let's see, if I want to create a script, and I can do that here as well. And type 1 + 2, and I can hope, and then well, I can save my commands here if I like, and do some any sort of operations I like. But I guess the main thing is I wouldn't encourage you to use that version of R anymore. We will use that version of R, but with a sort of interface that we use for R, we'll come to later, which we will use is this R Studio. So I guess the main point I'm trying to mention here is that R doesn't really care where the inputs come from, right? Or how we enter them. So by that I mean, when we are here, we can type in the code here, right, like I typed in 1 + 2, or we can use another bit of software and then send it to the R console and send it here. So this is sort of, if you think of this program more as a type of engine that we can use, but we can send things to that engine from other programs. Yeah. So we can write R code and scripts for our R code, and then we can send these R code scripts to run them at the command line, just like I typed in 1 + 2 before, and then we can save the R code scripts for future use, so we don't have to always type into the R console like I did before. So we're going to use scripts a lot, R code scripts, and this protects us if something happens, right? If R crashes or the power goes out or we close our R Studio session, then what we're typing here is kind of lost, okay? But if we write them in a script and save this as a kind of a simple text file, then we've always got a sort of backup version of every sort of command that we've written and sent to R. Okay, so there are a few, let's say, front-end programs that allow us to write code, and we can feed it into R. So we're going to use this R Studio, which is probably by far the most popular sort of front end for R. And the idea of R Studio is that it allows you to sort of write R code scripts and then interact with R directly from within R Studio. So let's just open R Studio. I think I have it open already. Okay, so here's R Studio, and you can see it looks a lot like R. Okay, we've got like the R console just like before, and again I can type in a command into there, and what it's really doing is it's using the R program already installed in on my computer, and then is interacting with it via R. Okay, so usually we let's go back to the slides. I think I'm getting ahead of myself here. Okay, so R Studio does what the original version of R does, but it also has sort of added functionality, right? So it has these additional windows in R Studio that help you to edit code. And when you're writing scripts, then you can sort of save your code. And there's sort of some very nice features where it will highlight different parts of the code, so you can separate what's between a function and what's between some data, for example. It has sort of a nice sort of spacing to it. Has some auto-completion, has a spell check on the text. So all these kind of things that when you're writing in the R sort of script editor, you don't get, but with R Studio, you do get it. You can also monitor and save and load your workspaces using R Studio. So there's a panel, I'll talk about this in a little bit, where you can see which objects you've created, and so sort of bits of memory that you have, and allow you to view a little deeper. You can also see the history of your past commands, what you've sort of sent to R, and you can sort of browse the files and documentation, looking at the help files, and also sort of find where you are on your computer to load data. You can also view and save the plots in many different ways, and it also has a sort of little menu system for helping you install and update packages. And then other things I didn't really mention, but you can sort of search and replace, you can change the font size, change the themes, arrange the windows in a different way, and even when you're developing R packages as well, R Studio has lots of nice features. And it also allows you to interface with these sort of different online code repositories or places to host R code. So it's all very, very well integrated and quite advanced R Studio compared to the sort of standard version of R. So this is the download link for R, and just like with R Studio, and just like with R, it's just a matter of downloading the program, running the installation program, and pressing OK and agree whenever you're sort of prompted. Usually the defaults are very sensible. Okay, so just to talk a bit more about RStudio. So typically, when we sort of open RStudio, it will be divided into 4 panels, and several of those panels are then subdivided into multiple tabs. And each of these sort of have a special purpose that it's good to be familiar with. You can change the order. Okay, so here's the sort of 4 panels from a screenshot, an old screenshot, I should say, where you can sort of see 4 different parts of helping you manage your R workload. So let's go through each of these. So in the bottom left, okay, so in this part, this is what we tend to call the R console. So you can see it here, it says console already. So this console, where we can enter commands, and they're immediately executed by the sort of R software. So this is very similar to the sort of original version of R that I opened up earlier. And we can sort of type things in there just like we did before, and it's going to give us the answers just like we saw with 1+2. So the console is sort of like the standard R program. It doesn't really care where the inputs are coming from, so we don't have to type into R into the sort of R console directly. Yeah? So this is where what's on the top left. Let me just flick back on the top left up here. This is where we usually write our code, and then we can sort of save it here and send it down to the R console using a shortcut command. So yeah, in the top left is what we call the editor. And so this is where we can store our R commands, and RStudio, we can open lots of different R files for editing, and running parts of that script, or the whole bits of the script at each time. So to create an R script file, we can select File, and then New File, and then R script. So let's do this, and then just to sort of see it working. Okay, let's close this one just so we can see. So we can either click on the button here with the plus, and it's a sort of new script here, or we can go File, New File, R script. Yeah. And what we can do is then type our commands up here. So I just type 1+2, for example, and then I don't need to highlight it. I can just press the Run button here, and this will send the code below down to the console and run it for us. Okay, so let me do another one. Let's do 4+2 and run. Okay, so you can see each time when whatever, let me do a second line, like 6. Okay, and then every time I press run, it's going to run the line of code where the cursor is placed. And once you press run, it's going to go onto the next line of code, ready to take it in. So I can start at the top if I want, press run, and it's going to run the 2 in sequence. Okay. Okay, so there are some shortcuts. We don't always have to press. Well, it's you sort of get used to not doing the mouse click now, and rather you can press Control R in some version. I think on the Mac version this wouldn't work, but on Windows it works. But usually I use Control Enter. So that is the same as pressing the Run button, right? To press Control Enter, and then we can highlight multiple lines of code as well. And if we want to run more than one code at a time, and so we can use the Shift button and then press up and down, or page up and page down, and then press Control Enter. We can run all the code by pressing Control A and then Control Enter. So let me just show you some of those. Okay. So here I'm just going to press Control Enter rather than clicking on the Run button. Okay. So each time it goes down. Or I can go to the top and then press Shift now, and then I'm just pressing the down button, highlight everything, and then it runs everything that's highlighted rather than one line at a time. Again, the shortcut for running everything is to press Control A, and it highlights everything in the script all. And then again, I'm going to press Control Enter, and it sends it down to the R console. So these are good shortcuts to get familiar with, because you'll be doing this many times if you're starting to work with R. To run the code. Okay, so hopefully you sort of get the idea that we can write in the editor, and we can write our own scripts, or we can sort of open pre-saved scripts. So in the handout file, I gave you the scripts that sort of underlie the R code in the slides. So for example, we can open one of them now. So let me go to, okay. So if I go to the slides code, and you can see for these introductory slides, I've got a script file, and you can see these bits are just first few lines you can ignore. They're to do with making the PDFs, but you can see here as we go down, these are just more of the R code that is contained in the PDFs. So we can highlight bits of these, right, and press Control Enter and send it down in our own R session. Yeah. So we will come to this later, right? Mean and so on. Okay. So this might be useful for later on in the course, where you might want to rerun some of the analysis that I've done in the slides on your own computer. Okay, so this is just what we did before. We sort of highlighted this code and just ran it in R. Okay, so continue. Let's go back here to the R Studio. So we talked about the editor, we talked about the console, and then I think we're going to talk about these two other panels next. Okay, so in the top right, we have this workspace tab. And what this workspace tab is sort of shows the objects that are available to the console. And yeah, these are sort of subdivided into different sort of sections, depending on whether they are sort of a data frame or a function or yeah, the sort of characteristic of what's being stored there. So if we create a data frame, then we're able to view it in a separate viewer. So I'll show this in a second. Yeah, and if you click on other objects, sometimes you can also edit them using like a small editor. So let's take a look at this code. So I go back to here and just comment there. So I'll talk about comments later. Okay, so I ran this bit of code, and what it has done, because of the arrow here, we'll talk more about the arrow later, but this creates two R objects, right? One in each line. And one is a data set, and one is a sort of a column, a single column of values. And if I click on the data set, then it's going to open up this new window where I can sort of, looks a little bit like Excel, right? We can sort of view the data in more detail. So this is based on this cars data set, which is sort of pre-installed with R, but I'm just sort of showing you how we can create our own data sets by clicking on the objects in the Object Explorer here. Okay, so next to the Workspace tab is a History tab, and this gives us a sort of set of commands, historic commands that we've already sent to RStudio. So we can save these histories if we like, or we can also search through the histories. So this is useful when you sort of something crashed perhaps, and maybe you didn't save the script. You can go back and find out the previous commands that you used, and you can transfer individual lines from the histories or sections of lines back to the console or the editor. So let's just have a look at that in the history. So if you look here, these were just this was the last thing I did, was the view D, and then before that, these were sort of the commands. I remember right at the start I was doing 1 + 2. Yeah, so you can sort of see, if I want to, I can highlight it, right, and then I can send it again to the console. You see it appears down here, so I can run it, or I can send it to the source. So then it opens a new script and saves it here. Okay, so I would say I don't use the history too much, but it's useful to know it's there, and sometimes it can really save you. So it's kind of like a messy version of scripts, right? It's got all the sort of commands that you sent to R, including the ones that might have been a mistake or that you later revise. Whereas in the scripts, we tend to save everything we want. Okay, so we'll skip to the bottom right of RStudio. So here there's a number of tabs. And so the first one is the Files tab. So this is sort of a simple file manager in which we can sort of open, move, and rename files on the computer. So let's look back here. So you see in the Files tab, I've opened it to the handout folder. So you can see this is the address on my computer. And then you'll be able to sort of go into folders here and back up using the sort of tree branch here. Or if you wanted to, like a PDF, we could open that by clicking on it, and it would open up. Oh, but I don't want to do that yet. Okay, let's go back here. So next to the Files tab is a Plots tab. So this is going to display plots that we create using the R script, and we can navigate through them using some arrows. So let's have a little play with this. So let's do, so we look, see plots, there's nothing there yet. I'll go back to File and let's do plot cars. And then we see we get a plot of the date of the cars data. Let's do a second one just so we can see how we can navigate through them. Do a histogram. Okay, and you see, once I did the second plot, we have these arrows which allow us to flick back and forward between different plots. And depending on how big your sort of screen is, basically, you can use the zoom button, and this will create a bigger version in a separate window, which can be quite useful when you're working with a small computer and perhaps the plot can be very small. So you can drag these to make them larger and smaller, each of the windows. And these buttons are quite useful as well. They sort of expand up and expand down the different parts of the windows as well. Okay. So next to the plot tab is the package tag. So R has thousands of packages, like I mentioned, and this packages tend to contain collections of R code that allow you to sort of use new functions. So when you load up R, there are 7 packages automatically loaded. So we can sort of check out which packages are using the global environment drop-down tab. So let's just have a look at this. So let's go to the packages. So this is going to look on my computer, I believe, and it's going to list all the packages that I've installed. So it's going to look different on your computer because for sure we wouldn't have installed exactly the same packages. And this is over the last few months since I updated R. So I've got I don't know, a few, maybe 100 or so packages here. And you can see we can update any of these if we like. And we can also click this and it will show a kind of a menu system to install. Okay, let's go back to the global environment, and as I was talking about in the slides. So you see here, it says global environment, and next to it is a sort of drop down. So in this drop down, there are 7 packages here, or 1, 2, 3, 4, 5, 6, yeah, 7 packages. And these 7 packages are always loaded when you load R. And so these contain lots of different functions. Like, for example, we were using the function plot before. This is in the graphics package, I believe. So this sort of stores everything that you sort of basic functions of R. And like I said, we can, once we install a new package, then it will join this list. So once we load a new package, I should say. So let me load a package, for example, library read Excel, which we'll come to later. It's useful as a package for importing data from Excel. So I use the library command to load the package. And then when I look back in the global environment, you see at the top now, there's 8 now, the 7 plus the read Excel package. So this is really how R works, is sort of searching through this package list to find a function that you might be calling, right? So for example, in read Excel, there's a function called read Excel. And then I could type in the file name that I want to import. And it's found that read Excel function by looking through this tree and then looking first in the read Excel package for that function. For example, when I'm using the plot function that we used before, you see right next to it, when it pops up in this R Studio, it says it's in the graphics package. That means it's sort of searching down this tree, can't see a plot function in read Excel, can't see a plot function in read stats, but can see a plot function in the graphics package. So it's sort of a sort of search order that it's going to look for whenever you type a function name. Okay. Yeah. Okay. So this is sort of pretty much everything about packages that we're going to cover. So the 4th tab on the bottom right is the help tab. So this helps. This displays the help file. So every function in R will have a help file, and we can launch the help file by putting question mark before the function that we're interested in learning a bit more about. So for example, let's do plot. If I just put, I went down to the bottom. Let's go back up here. If I do question mark plot, then it says there's 2 plot functions. So we can just click on the graphics one that we were using before. And then it's got the help file that sort of tells us all the information about the different inputs they can go into plot and sort of different things that we can control, and some references. And for example, we'll go through plot files a little bit later. Oh, even here. Okay. So yeah, we'll talk about it in more detail in the slides. Okay. So whenever you come to a new function, it's always useful to sort of look at the help file to understand sort of possible inputs and understand the default inputs that are being used. So just like we did for the plot function just then, we could do it for the log function by doing $log. And some functions, well, very few functions, you might not work to do the question mark, especially, for example, if you want to look how plus works, then you can write, you can't write question mark plus, it will give you an error message. So for a few functions, usually the one character, you can write help and then quotation marks and then the function name. But usually question mark will always get you to the help file. So each help file is structured, has a very similar sort of structure to them. So at the top, you get this sort of name of the function, and then in the curly brackets is the package that it's based in. And then you usually get 1 or 2 lines describing what the function does. And then you get some example of the function usage. So the function's name and then the input names that go along with it. So for the mean function, it only requires sort of one input, which is x. But it also has these options for handling missing values. This is what the NA remove means, or trimming values. So this is kind of like a template, if you will. And then below the usage is the argument section. And the arguments are sort of talking about these inputs that we can use, the name of the inputs, and then a little description about what they should be, what it's expecting to come from them. So here it's for the NA remove, for example, it's saying it's a logical value, right? So that means we'll talk about logics a bit later, but that means we need to put true or false whether we want to remove the missing values. Okay, so a bit further down, the help file is so the values. So this is telling you what comes out of the function and how that might be affected by the different inputs. And then we get some references usually, just to sort of if you want further reading. And the C also part is also quite useful. Perhaps if you're searching for a function, then you can give you other related functions that might be helpful. And then the example code towards the end gives you sort of code that you can copy and paste and run in the run in your R console, just to really get a good feeling of how it works. Okay. So a bit more on R help. So when you install R, it comes with an official manual, but you can launch that using help.start. But I would say that manual is I pretty much don't use it because it's very big, and the English is well, it's quite technical. Let's say that. So it's not always super easy to understand. So usually when I get stuck in R, which happens a lot still, I usually go to the internet and go to some of the sources that I will talk about towards the end of the course to find help. So I mean, it's always good to remember that R is quite popular now, so lots of people learn how to use it. So there's lots of help available on the internet. Okay, so maybe we talk a little bit about R packages. So I sort of mentioned this before, but there are many R packages, and to install them. Oh, sorry. Yeah. So let's start again. Yeah. So there's many R packages. To install a R package, we just need to run the command install.packages, and then inside here we put the name of the package that we want to install. So there are over 10,000 R packages to sort of choose from. And let's just maybe let's try it on my system. Okay. So I can write install.packages. And then I need to put the name of the package that I want to install. So, for example, let's do this megas, which is a package I wrote, and I'm not sure I've installed on my new version. So what's it doing? It's you see, it's running the code, and it's connecting to the CRAN server locally, and you can see it just popped up with a window saying it was downloading. And then you can see it's just giving us the sort of download information here, and then it's saying that it was successfully unpacked, which essentially means it's ready to install. So it should appear now in the list here. Now, what was it? Megast. yeah, so this is where I just installed it. So you see, once I've installed the package, this is a one-time operation pretty much, unless you want to update the package or update R. And once you've installed the package, when we look on the global environment, nothing has changed here. Yeah. So all you've done is install the package on your computer, but for R, the R version, this sort of our current working environment, it hasn't made any difference. So that package is only sort of installed on the computer, but it's not loaded. Yeah, because as I said, these 7 packages are loaded each time we start R, but the sort of hundreds of other packages that you might have on your computer are sort of not loaded. So to load each package, we need to use the library command, and then we can write the name of the package that we want to use, and then this will load the package for us. And we just get a little warning message, but we don't need to be afraid of that. And that's just because I need to update my R. Okay, so this is just describing what I just showed, that when we do install.packages, it connects to the CRAN mirror, and then it installs the operation. We usually only need to do this once, install.packages. And sometimes a package will depend on other packages, so it will install the dependencies of the other packages as well. And yeah, if you want to sort of choose the CRAN mirror, so there's about 50 odd mirrors around the world. So sometimes the default one tends to be the RStudio one if you've installed RStudio, but you can choose one more locally to you if you really have a slow internet, using tools, global options, and packages. And sort of choose a one that's located closer to you if you're really struggling with the download speed. Okay. So I would encourage you all, for most of the rest of the course, we're going to use these packages in the tidyverse. So if you do install.packages tidyverse when we come to the next break, and usually that's going to install about 40 to 50 packages for you. So it's going to take a few minutes usually, depending on your internet speed. So it's good to sort of do that before we get to the exercises. So this is just a slide I've put in that sort of useful for whenever I encounter problems with students and installing packages. I don't think I will go through it, but usually the common sort of problems that you might get, at least on a Windows, is when the Windows username doesn't contain sort of just Latin characters, right? So if you have a Korean username, for example, with Korean characters, then you can get into some trouble. And so these are just different, depending on the problem, different sort of solutions that are going on. And yeah, occasionally you might get in trouble, this last point, with certain bits of certain installation of packages. And so this is one typical way around that, is to set the type as equal to binary and build the package yourself. Okay. So this is just a further point that I already went through in RStudio, is that once we've installed a package, R is still sort of clueless about how to use a function within that package, that we need to load the package that we want to use each time we started a new R session. So we only have these 7 packages loaded by default. So for example, in this R session, in the slides that I was working with, when I do question mark read Excel, it gave me an error message. It couldn't find the help function. So I can load the package, and then I can have a look at the read Excel after I've loaded the package. Then I can sort of use it. Okay, so like I said, there's lots of packages, and they're updated. Well, some packages are updated frequently, some are sort of rarely updated. It really depends on the developer, and there's no sort of schedule for everyone to maintain. If you want to update your packages, which is it's good to do once in a while, you can do update.packages, or you can do an RStudio using tools and update package, and then click on the package that you want to update. Okay, so just a final few points for the course before we take a break is that I sort of ask for patience. That teaching R is not as easy as teaching some other subjects. It's never sort of smooth, and often we can run into problems on the course that people have different computers, different R versions, different package versions, so it can take us some time to find out. Throughout the course, I've sort of left these spaces, as I mentioned before, for doing exercises. So I sort of appreciate that doing the exercises can be painful, and I would sort of encourage you to get used to sort of feeling a bit frustrated. This is really the way that you sort of have to learn R, is just by getting frustrated a while and sitting and thinking about it, and that sort of that kind of learning process. It's not easy. If it was easy, then we could sort of do it very quickly. And usually the problems are always very minor, like you forgot to close a bracket, or you just misspelled the function name or the file name, for example. It's usually something to do with a typo. So just remember it's going to happen. It happens all the time to me, and I've been using R for now like 15-20 years, so it's really just part of the process. And yeah, the final point is that if you really get stuck, the solutions are in the exercise solutions folder, so it's there's always the sort of answers there for you. So I would encourage you in the break, or when you get time at least, is to install R and RStudio, and try and install an R package like Read Excel or the Tidyverse, and make sure that you can load that package up on your computer using library Read Excel, for example. Yeah, and then the final point is, if you're having trouble installing R or RStudio packages, then I've got this RStudio Cloud project set up with sort of the functions of the course up there, or the files of the course. So if you click on this, it's going to open the browser and take you to a version of R on the web, which has very limited capacity, and sort of a free version of RStudio. And you can log in. You have to sort of create a login at first, and then you'll see it's going to look like RStudio basically, and then we can sort of play around online as well. If you really have difficulty installing R on your own computer, then we can use this cloud version as well. I'm going to take a few seconds, I think. Okay, let's see. That's the last slide, so let's just wait for this to load. Okay, so here you see this is all loaded up now. I've already installed all the packages here, so I know it's sort of ready. And we've got the exercises and the solutions there if you want to work with them, and the data. Okay, so perhaps we take a break then, and then we come back in 10 minutes or so to go through the next set of slides. Okay?
Okay, thank you. Okay, we will back in 10 minutes. So now it's 2:53 in Korea time. So we will resume the lecture at 3:53